All right, ladies and gentlemen. So we have a quiz coming up, and I'm going to give you a quick little review of what this is all about. So the quiz is going to be pretty much exactly like what you see right here. There's no reason everyone doesn't do absolutely fantastic on it. So all I'm going to do, the quiz is going to look just like this. I'm just going to be changing the atom. So instead of being lithium, I'm going to make it sodium or something. So let's just take a quick look at this, the procedures here. So let's just go over the periodic table quickly. Valence shells, those are the outside electrons on the very outside shell. An ion is a charged particle, and these are the charges for the atoms. Okay, remember that the carbon column and then the hydrogen or the helium column, they have no MCI, so they have no charge. So let's just start off with this right here, kids. So what is lithium's MCI? Well, that means most common ion. So find lithium. Here's lithium right here. Lithium is in the first column, which means it's a +1 charge. So lithium's most common MCI is lithium with a +1. It just makes total sense. Magnesiums would be a +2, borons is a +3, oxygens is a -2. If you set your periodic table up and write all over it, you'll have the answers right in front of you. You'll finish this quiz in about 3 minutes. Other people are going to take an hour. So let's go again. So we have lithium's MCI. How many protons does lithium have? Well, remember that when we go to the periodic table, this is it right there. So lithium has 3 protons, ladies and gentlemen. 3 protons. All right. How many shells does lithium have? Well, remember the first row would be shell 1. The second row would be shell 2. But we are talking about lithium's MCI. So make sure that you follow that. So let me drop for you. So you're going to have the protons. So you have lithium, right? And lithium's a plus charge. But just to figure out how to do it, there's our first shell right there. Our second shell, we always draw as blue, right? So there's our second shell. How many electrons do we have? Well, this says we have 3 electrons. So we have normally 1, 2, and then we have 3. But since lithium has a +1 charge, there must be 1 extra proton, then electron, right? So how many electrons does lithium have, lithium ion? Well, so you can see that lithium has 3 protons. It's got a +1 charge. So the total charge is going to be the protons and the electrons. So there must be 2 electrons, which leaves us our 1 positive charge right here. All right. So how many electrons would we have total? 2. So we're going to take this, and that means we're going to clean out this outside shell right here. So when the question comes up, how many shells does lithium ion have? Lithium ion, ladies and gentlemen, is going to have 2 shells. Okay, how many valence electrons does lithium have? Well, lithium ion. Lithium has 1 valence electron, but lithium ion is going to have 2 electrons in the outer shell. All right, it's going to have 2 electrons in the outer shell. So that's going to be 2 valence electrons. And let's draw the Lewis structure. Well, the Lewis structure always deals with the outside electrons. So it's Lewis structure. You'd put Li with a plus charge, and then we would draw 2 valence electrons. So those 2 electrons, and that would be the Lewis dot structure. Okay. Okay, so when we take a look at silicon's MCI, please remember that silicon and every element that's in silicon's row, and we'll put silicon right here. Silicon is in the column right here that says no MCI, no common ion. All right, so silicon's MCI, when it asks you this question on the test for either carbon, silicon, or germanium, there is no MCI. So what you're going to do is you're just going to draw it regularly as just plain old silicon. So the question says, how many protons does silicon have? Hopefully you can see right here, it has 14 protons. How many shells does silicon have? Well, you can see that it has 1, 2, 3 shells. It doesn't have a charge, which means it hasn't gained or lost electrons. So there are 3 shells. All right. How many valence electrons does silicon have? Well, the valence electrons are the outside. The number up here, 1, 2, 3, 4. It has 4 valence electrons, so there'd be 1, 2, 3, 4 valence electrons. So there's 4 valence electrons. And then if there's 4 valence electrons, sorry, my pen stopped writing. If there's 4 valence electrons, then that's going to help us with our Lewis dot structure. So we always draw the number of, and I'll change the color for that. We always draw the number of valence electrons around the Lewis dot structure. And that's going to be 4 valence electrons. You can see it right here. 4 valence electrons would be 1, 2, 3, 4. And that would be the Lewis structure for silicon. Now remember, these are the exact same questions that are going to be on your exam, except for me changing the particles, atoms, the ions. This one says organize these from least to most electronegative. Now remember, ladies and gentlemen, electronegative means, right? Let me put that back. Electronegative means how tightly these are going to hold on, how tightly an atom is going to hold on. So something that is more electronegative holds on to electrons tighter. Something that's less electronegative holds on to electrons looser. Looser, I think that says loser. So let me rephrase that one. No, looser, L-O. No, that's correct, loose. All right, so what's gonna have something hold on tighter? Well, smaller atoms are gonna hold on to their electrons really tight, and bigger atoms are gonna hold on to their electrons less tightly because the electrons are so far away. So you can pretty much set these up to atomic size. So let's just take a look at these. We have to organize these from least electronegative to most electronegative. So let's put down here least electronegative and most electronegative. Now, let's just take a look. Let's find these right here. Let me get this out of our way a little bit. So let me move that out of the way. I think I've covered everybody down to there's platinum. Good. So if we take a look, let's find them. So we have, what do we have? So let's see, we have antimony, tellurium, iodine. Okay. So we have those 3, and then we have lead and bismuth. And we have lead and bismuth. And we have to take a look and say, which ones of those are going to be most or least electronegative? Now, you can take a look at this one. This one's on row 5, and this one's on row 6. So right away, we can take these 2 right here and say, well, these are row 5, and they're going to be much bigger, which means the electrons can't hold on as tightly. And then these are going to be row 4, okay? And since those are on row 4, they'll be able to hold on to the electrons a little bit better. So least is going to be lead and bismuth. And we want to say, well, which one would be least? And if we take a look, we have lead, which has 82 electrons, and bismuth, which has 83. So lead is going to hold on the least. So we can put Pb, and then next would be bismuth. So then we have those taken care of because those are on row 5. And then if we look up here at row 4, we have antimony, tellurium, and iodine. And we want to say, well, which one of those is going to hold on to the most? And for me, I would say, well, the smallest of those will hold on the best, the one with the most protons. And that's going to be iodine. So iodine will be the most, and then it's going to work itself backwards. And I'll be like, okay, and then we have Te and antimony. Okay? And using that information, we could say, just the idea is that more protons will be smaller. That holds on tighter. And conversely, less protons on any one row would make something larger and it would hold on less. So if you can keep in mind that the further up we go, these are the most electronegative, and these are the least electronegative, right? That's going to help you find the pattern that's embedded in the quiz. Now, on this next question, this next one says, determine which of the following atoms is bigger, okay? It should say particles. So that word there should say particles, okay? Because that one is not an atom, it's an ion. So determine which of them is bigger. So we're looking for bigger. And then the key says, explain why in one complete sentence. So there's a couple of tricks that we taught you to figure out. I taught you to figure out whether or not something's bigger or smaller. And the first thing you want to take a look at is you have calcium or calcium ion. When you look at it, the first thing you want to do, you want to look at the number of shells, right? Then you want to look at the number of protons. Then you want to look at the number of electrons. So let's take a look. So if we take a look at this here, right? We can say, well, how many shells does calcium have? Calcium is right here. Calcium has 4 shells. How many protons does calcium have? Calcium has 20 protons. Calcium's a neutral atom because there's no charge up here, which means that the protons must equal the number of electrons because there's no charge, which means that the electrons are 20 as well. Now, if we take a look at this calcium ion here, we can look and we say, well, how many protons? Well, we can look at the shells, but when there's an ion, maybe we're not sure about the shells. I'm going to help you figure that one out. But we know that there's going to be 20 protons, and we know there's going to be 2 extra protons than there are electrons. So there must only be 18 electrons. Why? Well, because we know there's 20 plus charges, and there's 2 more plus charges than are negative, so there must be 18. If you're struggling on that idea, watch this section again and practice some yourself. All right, now let's look at the shells. So calcium, ladies and gentlemen, has, look, calcium has 2 valence electrons on the outside, right? So calcium is going to be like this. Calcium would be drawn with 2 valence electrons on the outside. Now, is calcium going to want to gain 1, 2, 3, 4, 5, 6 more electrons? Or is calcium going to want to lose just these outside 2 electrons? Well, calcium is going to want to lose these outside 2 electrons. And in doing so, what's going to happen? Well, calcium is going to look like this, ladies and gentlemen. So with Movie Magic, I just drew this out. So this would be the shell model for calcium. So if we take a look, you can see that calcium has 1, 2, 3, 4 shells. 1, 2, 3, 4 shells. Calcium has 2 valence electrons on the outside. Each shell wants to have 8 valence electrons. First one has 2, and then we have 8 and 8. Calcium can either gain 6 more electrons, or calcium can lose those 2 electrons. And hopefully you're saying, yeah, calcium's going to lose those 2 electrons. And in doing so, calcium becomes, whoops, sorry about that. Calcium becomes a 2 plus charge, loses those outer electrons, and you can see that there are only 1, 2, 3 shells. Now, which one of these is going to be bigger if calcium ion only has 3 shells and calcium neutral has 4 shells? Which is going to be bigger? That's right. The one with 4 shells is going to be bigger. That's going to be the deciding factor. All right? So if you can break down which atoms have how many shells, then that's going to help you find right away which atoms are bigger or smaller. So this last one is going to be figuring out which one of these atoms, we're going to order them from smallest to largest. So right over here, in this bottom corner, we'll write smallest. It's always my suggestion to write the smallest over here, and then you'll write the largest on the other side. So let's take a look. First off, let's organize these. So you have fluorine, then you have fluorine's MCI, and you guys should know now that fluorine's MCI is a -1, okay? Or 1 minus, I should probably get rid of that, just leave it as minus. then we have neon, and we have sodium, we have sodium's MCI. So what's sodium's most common ion? Well, sodium is right here. Right, here's sodium, right? Sodium has a +1 charge. Now we have to organize these. So you can see we're working with fluorine, neon, and sodium. We're only working with these three ions. So we're gonna look and say, wow, which ones are gonna be bigger than the others? So remember a couple of tricks that we had, as we said, first, take a look at the shells, right? And then we said, take a look at the number of protons, and then we take a look at the number of electrons. So let's do that right now. So how many shells does fluorine have? So let's take a look. How many shells does fluorine have? Good, take a look. All right, I should have paused that for you. I'm organizing these other things. All right, so how many shells does fluorine have? Well, you can see that fluorine is on the second shell. And then fluorine ion, we said, sometimes it's difficult to figure out what the ion's charge is. But if you take a look, fluorine right here with one extra electron normally has 9. So now it's going to have 10. It's also going to be on the second shell. Neutral neon is going to be on the second shell. Na, it's going to be on the third shell. And then Na plus, you'd think it's right here, but this is where it has that last outside electron, and it's going to lose one electron. So it's going to be there. So right away, we can look and say, well, all of them are on the second shell, except for sodium. So sodium, that's going to be the largest because it's on the third shell. So there that one is. So we don't have to worry about sodium anymore. Okay? And then we want to say, well, what's next? Well, let's take a look at the number of protons. How many protons does fluorine have? 9. No matter what fluorine is, fluorine's always going to have 9 protons. Neon has 10 protons. And sodium has 11 protons. So we can, sorry. I thought I did that wrong. I thought I put the wrong one here. So, ladies and gentlemen, so now we can take a quick look and say, well, let's analyze this. They're all on the second shell now, right? And all of them have 9 or 10 or 11 protons. So what can we do? Well, which one of these is going to be the smallest? That's the question. Can you tell? Well, this one has 11 protons pulling in. And remember, we said you have the protons pulling in on the electrons. And since they're all in the same shell, the ones with the most protons are going to pull in the most. So Na plus 11 protons is going to pull in really hard on its electrons, thus giving us the smallest, which is going to be Na plus. That'll be the smallest of all of these. And then we can take a look and we can say, well, what would be next? What would be next? I'll just draw that in green. What would be next then, ladies and gentlemen? Well, the neon is going to be next, right? And now we have to figure out what's it going to be. Is it going to be fluorine or fluorine ion? Well, let's take a look at the electrons on this one. So how many electrons? We would have 9 electrons here, right? We would have 10 electrons there, right? I'm going to cross this one off here. Okay, so that one's gone. So you would say, well, which one of these is going to be the next biggest? So you have 9 protons pulling against 9 electrons, and then you have 9 protons pulling against 10 electrons. And which one of those, just depends on how you think, is going to be able to pull them in closer or not pull them in as close. I like thinking which one would make it smaller. And in this case, the 9 protons is going to be able to pull further on those 9 electrons. Thus, that would be fluorine would be next. And then finally, you would say, well, then this one must be in between because we knew that Na was the largest because it was on the third shell. So then you'd have F minus. And you're going to want to be able to do that on your quiz. Now, remember, the quiz is going to be exactly like this. So take a look at this work, review it, and then we're going to start our quiz and finish it up. Hopefully, you guys have taken this time to learn all of your information, and you're going to do well on the quiz. I really hope you are. Your homework has been fantastic. You guys have been getting, the correct answers. So hopefully you do well. I'm sitting right here if you need me. Good luck.